the previous videos, we mentioned about the importance to take into considerations the construction process on site so that your design of the reinforced concrete structures can be properly synchronized with the works on site. This is very important as it is one of the important factors that governs the productivity as well as the quality of the structures. You know that the site also involves a lot of parties to construct various parts of the structures, and there will be many layers of supervisions as a part to control the quality of the structures. Not only your design need to be technically viable, you need to consider the supervision part done by various parties within the contractors, representing the main contractors, representing the consultant, and etc. Next, we will further our discussions into another topic which are commonly missed by the students. That will be the water leakage issue, which we have mentioned quite a number of times in our previous videos. You need to know the functionality of the structures is also a part of the design. There will be occupants in the building and there will be usage of water. You know that concrete is not totally waterproof unless it is properly designed. There will be requirements in the Eurocode in terms of the design, controlling the crack width as a measure to control the leakage of the waters, which in this case, you will need to design accordingly. What local industry normally practice, it will be providing additional reinforcement bar, where the spacing of the reinforcement bar within the slab will be closer than the typical slab. Most likely it will be Y10 150 mm spacing in both sides, and there will be double layers of reinforcement bar, a layer at the bottom of the slab and another layer on top of the slab. This is especially applicable at the places which is likely to contain water, such as the toilet, the balcony, or certain drop surface which is exposed to the rain. You cannot fully rely on the contractor to provide coating at those parts, as you know some contractor may not provide it even though it is required by the architect. In the case that lacking of supervisions, or in the case that it has already been covered by the finishes and tiles, it is very difficult to cross-check whether there are damp-proof coating on those regions, and this is normally not noticeable by the client as well. Sometimes this water leakage issue may not be fully surfaced out during the defect liability period, which typically are within the 12 months after the building is handing over to the client. But you know that ultimately if you have problem with the water leakage, it will lead to you structural problem in long term. You are afraid of the corrosions in the steels embedded in the slab. When this is excessive, it will lead to the structural problem. There will also be watermarks on the ceilings or on the floor slab, which is going to raise the concern by the occupants of the buildings. This in another way will affect your reputations. It is our obligations to deliver professional service to the society, and by right, this should be properly designed. Therefore, be careful with the water leakage issue. Make sure you are aware of this. There is another thing that you need to know. It is due to the limited allowable space within the ceiling. You know that the purpose of the ceiling, especially for the buildings nowadays, they are very concerned with the aesthetic view, where a lot of ugly things, which seems to be quite messy, are to be hid within the ceiling. This including the ducting and the services, which are sometimes to be hid within the ceiling, not to be seen by the general public. You have to be careful with your design also, which if you observe from the architectural drawing, normally they give you the intended flow of the waters from the basin, from the toilet, from the floor track towards the drainage or towards the septic tank. Typically, ceilings are given with the height of about 600 mm. If you use up full 600 mm as the beam height, that means you are blocking the pathway of the ducting and services, especially when you talk about the first floor plans. Now you need to have the ducting and services passing through the beams. You cannot allow the services to pass under the beam as you don't have sufficient space, and if you pass under the beam, it will be seen by the general public. That means the most feasible way to do it, it will be passing through the beam. That means the contractor is most likely going to create a transverse opening on the beam, providing the passage of the ducting and services. Something like this. In this case, you have a beam here, and this is meant to hang the ceiling. They don't have sufficient space for the ducting to pass underneath the beam. The only solutions it will be passing through the beam. They will need to create a circular opening if you are talking about the surface pipe, which for typical commercial as well as the residential usage, the pipe size it will be PVC 100 mm diameter. That means your opening size is most likely going to be somewhere between 125 to 150. Sometimes there will be rectangular transverse opening. That one is meant for the air con ductings. It will be dependent on the service system used in the building. You know that whenever you have an opening onto the member, the performance of the member will significantly be affected. The beam will have lower shear capacity, and the moment capacity will also be significantly affected. You cannot simply allow the contractor to penetrate through your beam without extra reinforcement. And normally when you come to this extra reinforcement, it's going to be quite extensive, trying to compensate the losses in terms of the capacity due to this transverse opening. Most likely you know that which beams is going to be having this transverse opening. As observed from the architectural drawing, you know the pathway of the piping as well as the services. If you foresee that they don't have sufficient space, let's say now you're talking about a PVC pipe of 100 mm, you need to have at least more than 100 mm space underneath the beam but above the ceiling, and then the transverse opening is not necessary, which in most of the cases the space within the ceiling is quite limited. Then for this kind of member, you need additional longitudinal reinforcement bar, and you need to provide the reinforcement surrounding the opening in order to strengthen the openings, both for the circular sections and rectangular section. You know that circular section is still okay as it doesn't have these orthogonal corners, but when you deal with the rectangular or square opening, this will be a bit headed, as the stress can easily concentrate at the corners of the opening, and the member can easily be tear apart under loading. Therefore, you will require reinforcement to strengthen the corners of the openings, having the reinforcement aligned at an inclined surface perpendicular to the potential path of the cracking to prevent the cracking developing at the corners of the openings. On this note, you will need to provide a typical design to strengthen the circular opening as well as the rectangular or square openings. Clearly indicate how the reinforcement bar are being arranged, as well as indicating the size and numbers of the reinforcement bar. You will need to provide adequate anchorage length so that the reinforcement bar can act effectively in controlling the cracks. You will need to also consider the size of the beams that likely to have the opening. You would like the beam to be at a larger depth so that the opening size are kept within 1/3 of the height of the beam, as normally practiced by the industry. Preferably, based on some research study that you've seen in some journals papers, most of them recommend it to be not greater than 1/4 times the beam height, which in this case, if you're talking about 1/3 the beam size, for a typical beam of 600 mm, that means the maximum opening height must be less than 200 mm. Or if you're talking about 1/4, it will be maximum size of 150 mm. This at least you can ensure that the capacity of the beam is not significantly affected. For more information, you can actually read through certain publications which you can find online. They have specific research on this. As a rule of thumb, preferably it will be 1/4 of the height, as given by a typical researcher. Some would say that it will be 1/5, but what industrial normally practice, they are okay with 1/3. This will be very much dependent on your confidence level with the quality of the workmanship by the contractors. You know that there are good contractors, there are also poor contractors. This one will have to go back to the practical side, which you will see some engineers. If they know upfront who are the contractors, they may have some initial judgment based on the track record of the respective contractors to decide the degree of conservativeness that they're going to use in their design. There is not right or wrong on this matter, because engineers are also competing among engineers, providing economical solutions to the client so that they are awarded with the project. That means in the reality, some engineers are also cutting throats, playing around with their margin of safety, striking for the projects. Then if you know who are the contractors, you have high confidence that the contractors are accountable, they do all the work quite nicely, then you dare to go for more economical solutions. However, if you have no confidence with the contractors, or that respective contractors are well known to be cheap, but the quality of work may not be as competitive, there are also reasons that why clients engage such contractors, which on this note, you have to be careful with your design as well. This is one of the considerations as well. This brings to another issue, since that we mentioned it this here. You know that all the engineers, they come from the similar background. They went through the similar training in their university. They are studying the similar syllabus, knowing how to design every type of the structural element on basis of the similar standard, which at the end of the day, there are some engineers thrive in their career and there are engineers struggling hard in the industry. There are specific reasons out of it. To design a safe structures, as long as you follow the guide, as long as you follow what you learn in the university, every engineer can do it. To have your technical drawing to be fulfilling the technical requirement, which at the same time is friendly to the industry. This makes the designer to be more competitive in the industry. And if your design is technically okay, and your products are also very friendly to the users of your technical drawings, furthermore, you are able to produce really economical design. Your solutions are always easy and your works are details. That makes you a more competitive engineer. Therefore, producing technical drawing may not be as easy as you see. Some engineers may be producing the technical drawing for more than 10 years, which might not really been through the construction site, not knowing how it is being constructed. There is a reason why their technical drawing might not be as friendly to the contractors. I will encourage you, which in future in your career life, working as an engineer, although you are not fully obligated to be at the construction site all the time, at least you should visit the site once a while, talk to the contractors, observe how they do the work, see how you can improve your technical drawing to make it friendly as well as economical for the clients and the contractors. There's one more thing about the opening for the beams. Normally you will have to limit it not to have the transverse opening at the regions of maximum shear as well as the regions of maximum moment. It would be good if you have the transverse opening placed somewhere in between the maximum shear and maximum moment. For a simply supported beam, the maximum shear it will be near to the support, and the maximum moment it will be at the midspan. As for the continuous beam, this may not necessarily be true. Sometimes at the support, the maximum shear and maximum moment can occur at the same time. Sometimes due to the end condition, the maximum moment may not necessarily to be at the midspan of the continuous member. This you need to be careful. Since that we mentioned about the transverse opening on the beam, there are also cases that you need to create opening through the slab. This is especially for the purpose that the ductings and service need to pass through different stories. With that, you should also provide the technical details allowing the contractors to provide the opening through the slab. Again, you require additional reinforcement bar, and there will be reinforcement bar surrounding the opening. Especially when you deal with the square and rectangular opening, extra care will be required at the corners of the openings.